Hi, how are you? I'm back again to talk about hypothesis test for a population mean. If you like what you are seeing, please type a comment below the video and I will get back to you. I promise I will get back to you. So please don't hesitate to put a comment. Okay. So let me share my screen with you. Hypothesis test for mean population standard deviation not known. And US government states, or US government results states that a person between the ages of 18 and 34 had an average of 9.2 jobs. To determine if this average is correct, a researcher selected a random sample from the same age group and asked how many places they had worked. The results were, there are 9 numbers because they sampled um, randomly 9 people. 1, 2, 3, 4, 5, 6, 8 people actually. Okay. So at alpha equal to 0.05, alpha is Greek small a. What does it stand for? It stands for level of significance, which is the maximum probability of rejecting 80 when it is true. So the maximum risk we are taking in making a wrong decision is 0.05 or 5%. So at alpha equal to 0.05, can it be concluded that the mean is different from 9.2? Different from does not say greater than or less than. So my alternative hypothesis or the test hypothesis is mu not equal to 9.2. Equal to line drawn through it, 9.2. It means mu can be greater than 9.2 or less than 9.2. And the null hypothesis, of course, is mu equal to 9.2. Since we have the data points given to us, we have to enter the data in L1. In order to do that, we press the second button in the calculator, then the plus sign on top of enter, then number 4. And we get clear all list on our calculator screen. And after that, we press enter, and then it comes back with saying done. That means we have cleared the memories of the calculator. Okay. Now we have to enter the data. So we press the stat button and select number 1, which is the edit button. Enter data in L1. That means type each number in L1. Okay. In this problem, we do not know the population standard deviation. Since we do not know the population standard deviation, we will use t-test. So we press the stat button after entering the data, then highlight test on the top row, and then select number 2, which is t-test. Input is the first line in that screen. We put the cursor on top of data since we have entered the data in L1 and hit enter so that it's flashing on top of data. Mu0 is the hypothesized population mean, which we know from the null hypothesis is 9.2. List is L1, we will not change it. FREQ means frequency is 1, we will not change it. The fourth line is the alternate hypothesis. My alternate hypothesis is mu not equal to 9.2, which I have already told the calculator is mu0. So therefore, I put the cursor on top of not equal to mu0 and hit enter. So that is flashing on not equal to mu0. This is my way of telling the calculator that the alternative hypothesis is not equal to 9.2. Then I scroll down to calculate and hit enter. The first line I will get is the alternative hypothesis. The next line T is the test statistic, which is minus 0.53. What does it mean? It means the sample mean is away from the hypothesized population mean of 9.2 by minus 0.53 times the standard deviation of the sampling distribution. Since the sign is negative, it means the sample mean is below the hypothesized population mean by 0.53 times the standard deviation of the sampling distribution. Okay. Below the test statistic, we get the p or the p value of 0.612. What is this p value? This is the probability value of getting a t as extreme as minus 0.53 or more extreme than that, means more negative than that. So what is this? This is the area. The p value is the area In this case, the test statistic is negative, so it is the area under the T curve to the left of minus 0.53, T value of minus 0.53. And since this is a two-tailed test, the probability value to the left of minus 0.53 is multiplied by 2 to give us a final p-value of 0.612. Now, realize not equal to is a two-tailed test. Okay, that means the test statistic could either have fallen in the left tail or in the right tail. In this case, it fell on the left tail. So we compare the p-value probability value with the alpha value. Alpha is 0.05. So p is greater than alpha. P-value is greater than alpha. When p-value is greater than alpha, decision is do not reject H0. And what is the conclusion? At alpha equal to 0.05, there is not enough evidence to support the alternate that mu not equal to 9.2. Why is this the case? Because we have failed to reject the null hypothesis because the p-value of the test statistic is greater than alpha. Okay, so that is the answer to your question. If you have any question, please type a comment and I'll get back to you. Also, I'll come back each week with different solved statistics problems. So please subscribe to my channel and please give me some comment so that I can improve on my presentation. And I will respond to your comment. Okay, thank you and take care. We will see you next time.